Good day, dear students. Continuing to the introduction of engineering mechanics, I'm Professor Mayuri Patel. We'll be discussing further few important concepts which we need to uh, study before moving further towards mechanic numericals. Firstly, I would like to explain you what exactly a particle means or what we treat a particle as in engineering mechanics. So as you can see the definition, a body with mass but with dimensions that can be neglected is called as a particle. For example, as you can see here on the screen, the size of Earth is insignificant compared to its size of its orbit. Okay, so Earth can be modeled as a particle when we study the orbital motion. For example, all of us know that Earth has a very huge size, but when we are studying about the orbit of Earth, at that time the size of Earth is very negligible and hence it can be neglected. Similarly, such bodies which have certain mass but whose dimensions can be neglected while studying for a particular plane, those bodies are considered to be particle. Nextly, it is a rigid body, a combination of large number of particles in which all particles remain fixed at which are remain at fixed distance from one another before and after applying load. Such bodies are called as a rigid body. Means what? When I have a combination of different number of particles which are at certain fixed distance from one place to another despite of load applied on them, such bodies are called as the rigid bodies. Material properties of rigid body are not required to be considered when analyzing the forces acting on a body. Means what? Whenever I'm going to study about the force on a body, I'll be not considering about the material properties of what material that particular body or object is made up of. Here, using this example of contact force between a wheel and the ground, I would like to explain you about the concentrated force. Effect of loading, which is assumed to act as a point of CG. Yes, CG means center of gravity, which we'll be discussing in our further topics. So, provided the area over which the wheel load is applied is very small compared to the overall size of the body. Okay, so here we are going to study about the concentrated force. As you can see here on the first wheel, the load coming up to is 40 kilonewton. Here on the backward is 160 kilonewton. So how we are going to design. As we have studied in a previous lectures, what is kinetics, dynamics, statics, it all has a relation over here. Next important concept is regarding few important definitions. The very first one is length or space. It is not needed to locate the position of a point in space and describe the size of a physical system. Also, it gives me distances or the geometric properties of particular objects or bodies. Next important concept we need to know is that is time, which is nothing but it is a measure of succession of event and it's a very basic quantity in the dynamics. Mass is nothing but a quantity of matter in a body or a measure. It is a measure of inertia of a body or resistance to change the velocity of a particular body. Force. It represents the action of one body on the another, which is characterized by its magnitude, direction of its action, and its point of application. Whenever I need to go for force, there the magnitude, direction, and the point of application also matters and need to be considered while finding out the load on a particular body. Now let us discuss about what is Newtonian mechanics about. Length, time, and mass are absolute concepts which are independent of each other. Force is derived concept, not independent of other fundamental concept because, as we have seen in the further slide, that it is dependent upon the direction, motion of direction, etc. Force acting on a body is related to the mass of a body and its variation of its velocity with time. For example, gravitational force, electrical force, magnetic force. Yes or no? This force may also occur when the bodies are physically separated. For example, magnet. Even when we take two magnets apart from each other, still a certain force pulls them towards each other or away from each other, and that is nothing but a force. These are few points which I have noted down for you, which you need to remember. That is, mass is a property of matter and does not change from one location to each other. Despite of the change in location, despite of the change in direction, you can say magnitude of movement, the mass would not change its value. Weight refers to the gravitational attraction of the earth on a body or a quantity of mass. Its magnitude depends upon the elevation at which the mass is located. Weight of body is the gravitational force acting on it also. Okay, mass has no relation of location, but yes, weight has a relation because it directly relates with the gravitational force acting on that particular body. Here are the scalar and vector quantities. In the scalar quantity, we just go for magnitude only, whereas for the vector quantities are those in which we study about magnitude as well as direction. This table gives you the basic comparison between the scalar quantities and the vector quantities. Any physical quantity that does not include the direction is known as a scalar quantity, and the physical quantity which considers both magnitude as well as direction is called as a vector quantity. We will be solving the numericals for scalar and vector quantities, so I'm giving you the difference over here. One dimensional generally are the scalar quantities, and the multi-dimensional are the vector quantities. Uh, Scalar quantity changes its with the change in the magnitude, and the vector quantity changes with the change in the direction and magnitude both. Scalar quantity follows ordinary rules of algebra, whereas the vector quantity follows the vector algebra. Comparison of the two quantities is simple in case of scalar quantity, but in case of vector quantity is complex. Scalar can divide another scalar, but two vectors cannot divide each other. Yeah, these are few of the measurements which are the best examples for scalar quantities which are measured with numbers and units. First one is the length, the other one is temperature, and the third one is time. As I've said, vector quantities are those which consider magnitude as well as direction. The very first quantity is the acceleration. Generally, we denote it as meter per second square. Next is my displacement. Displacement is movement from one place to the another. It also matters with the magnitude and direction, hence it is a vector quantity. Next is the force. Force, whenever we apply certain object on some other person, at what magnitude and what direction we are throwing it matters, hence it is a vector quantity again. Yeah, distance is a scalar and displacement is a vector quantity. Similarly, speed is a scalar and velocity is a vector quantity. Because speed is irrespective of the direction, but yes, velocity depends upon the direction. Hence, speed is a scalar quantity, whereas velocity is a vector quantity. Here, the average speed and average velocity formulas are being noted. Average speed equals to distance upon time, whereas the average velocity is the displacement upon time. Yeah, so this in this particular slide, I'm giving you a brief, you can say, difference of measures or quantities which come into scalar or the vector. As we have earlier discussed, a scalar quantity is one which can be completely specified by its magnitude only, whereas in case of vector, it requires magnitude and direction both to completely specify different quantities which are that will be scalar are length, density, volume, energy, mass, area, speed, work, distance, temperature, time, moment of inertia, and so on. Whereas for the different vector quantities are displacement, force, weight, velocity, angular displacement, momentum, impulse, moment, and so on. Yeah. Now, here are the different unit vectors. A unit vector is magnitude of 1 with no units. This part would be further explained in the coming lectures. Here I've explained some by which rule we find out the direction of a particular object. As you can see here in the diagram, a right hand thumb rule is being obtained. The direction of C is perpendicular to the plane formed by the A and B. To find out the direction of a particular force, we can use a right thumb rule. As you can see in the figure, as the thumb goes in the upward direction, the upward, that is here in the diagram, the C1. So to find out the direction of C, we assume that it is perpendicular to the plane formed by this A and B. Now, the scalar and vector quantities would be explained to you in my further lecture, giving you the examples of numericals, but widely in what sense you are going to solve a problem. I've mapped them down. Initially, you need to read the problem, draw a particular diagram, says in what direction the force is going, what is the load applied on it, label all the quantities on it, identify that which equation is we are going to use, solve the equation and substitute your values, and then cross check the answers. The reference books which you need to follow for engineering mechanics are the very famous one and the most important is by SS Bhavikatti sir. It is very good book, so please use this book for your studies of engineering mechanics. The knowledge which you need to have before going for mechanics numericals, that is about your trigonometric equations, calculation, unit conversion, which I have explained in my further class, and balancing the equation for units. Please try to make note out your sheet regarding the SI conversions, unit conversions, so that it would not create a problem while solving the numericals. Thank you. In the next classes, we'll be studying actually the numericals on vectors and scalar quantities. Thank you so much.